This is Scott from KIG. It is July 2019, and we're going to do a couple informational and demo videos of this kind of special arrangement we have, which is a 5-ton chiller with a isolation exchanger. So what we have is we have this 5-ton Cold Rush series package chiller with a glycol reservoir and pump. This unit is going to be mounted outdoors in a cold climate in this case, and it's going to be running a glycol solution because of that. And then what we have is the chiller loop is going to be chilling this heat exchanger here, or the glycol side of this heat exchanger. And that part, or this component, these components that you see here, which is a heat exchanger, a pump, a motorized ball valve, and an array of fittings, and actually a temperature controller also for the ball valve. All this is going to be mounted indoors. So what we have is the output flow of the chiller is coming here to the inlet of the glycol side of the heat exchanger. Then we have, this is the inflow to the glycol side of the heat exchanger. We have this motorized ball valve, which is controlled by a temperature controller, which will go on the other side. You can see that there. That temperature controller controls this ball valve, which is going to control the inflow of the cooling fluid into the heat exchanger, or it's going to bypass it. This is the outlet of the glycol side of the heat exchanger. That's the white braided line. The outlet of that comes back to the inlet of the chiller here. So on the other side, let's call it the process side, we have this walrus pump. So in our test environment, this walrus pump, you can see the suction side of it there, is suctioning off of, or drawing off of, in our case, just our test tank. In a customer's application, this will be a much bigger tank indoors. In our two customer examples, or two customers who are getting a system like this right now, they're cooling down cutting oil or CNC cutting fluid, if that's the right term, which is going to remain indoors. It's not going to go out to the chiller. Additionally, there's a requirement to have tighter tolerance control than what a typical air-cooled chiller can achieve. So for that reason, we have this Inkbird controller here, which is similar to what you would see on fermenters or a bright tank in a brewery, which when it's in centigrade mode can be programmed to a differential of 0.3 degrees C. So what that means is that, for example here, a 24 degree set point, when it gets up to 24.3 degrees, which is the tightest differential that it can do, then we will open up that motorized solenoid valve, okay, thus introducing the chilled fluid into the glycol side of the heat exchanger. So that's going to just modulate back and forth based on the temperature of the process. So what does that mean? That means that the probe from this Inkbird controller basically comes right into this well right here. And that's basically measuring the temperature of what's being drawn from the process. So the reason we have all this, again, is because one, we're going to have an outdoor chiller, so we have this isolation exchanger to isolate the oil or the process from what's going on outdoors, and also for tighter tolerance and temperature control. Because in the world of chillers, we can't have a super tight differential, otherwise we'll be short cycling the chiller. So in this example here, we have a Ranco controller. Actually, we're going to power that up right now. This chiller right here has we have programmed also in centigrade. Let's see if we can get a good view. Right now the chiller we have set, for example, at 16 degrees Celsius with a differential of 4. And you kind of want a big differential on a chiller, otherwise You want to get away with the biggest differential that you can, otherwise the chiller will be short cycling itself. So I'm going to come back with video number 2 here in a second as we turn some things on.